Hello again. We're back. We're going to go ahead and grab the walls that we want. Not the roof and not the floor, just the walls out of here. And we're going to start throwing our surfaces together for that. So we can add glazing by ratio as a variable to explore that a little bit. So let's go ahead and discover what is what we don't want. I believe 5 is going to be cool. Yeah, we don't want that one. Okay, cool. We have our floor. Let's go ahead and label that with a group real quick. This one we don't want just because we'll just have it as one zone and there's not going to be an insulated or uninsulated attic. We're just going to keep the model simple. So let's just go ahead and make that unexist. That's still the floor. Cool. Good to go. Okay, so we have 3 of these, and we'll just add the these to their correlative walls. So we have all these surfaces. Now let's go ahead and grab everything and just move it down. Give us a little bit more room because this is going to get big, and then we're going to trim it up a little bit to keep the sim from being too heavy, which for me, I mean, I'm on a pretty powerful laptop, but I know I make messy simulations and stuff just because I use so much to build out the model. But I've learned that if once you get to a point where you can internalize data and not have all this thinking going on, it definitely speeds things up a little bit, which is nice. If you go to the Wallacei forums, there's tons of info on how to speed up your analyses, but I've just not spent the time to do that yet. Sorry. Now cool. That one's going to go with one of these, so we'll just drop that down there real quick. It's going to get messy for a minute. Grab another B-rep. We'll just copy a bunch of these. Move them up. Cool. That one is a wall that we want by itself. That one is one we want with there. And we're good to go. Cool. So let's go ahead and grab 2 of these surfaces. We'll throw these walls on it. Jam. Easy day. Now let's go ahead and kill these for now. Now if you come up to group 1, I had put together some information. Now let's go ahead and right click on that group and ungroup it, make group 1 go away. Now what we need to do is build up the constructions that are going to go into all the walls. They're going to be the same construction, so we're just going to do this once, don't worry. But we're going to make, let's call it my happy Bob Ross inspired wall cons. Clean the panel name. Cool. Now we'll do our siding. We'll do some insulation. Let's do an air gap, and then something gypsum-y would probably be nice. Maybe we'll mix it up. We'll see what happens. You know, Bob Ross always says there's no mistakes, only happy accidents. So let's keep pushing. So let's get an Energy Plus opaque material that'll allow us to input the thickness and all the other stuff. If you use the no mass opaque material, it doesn't allow you to set the thickness, and then this is nice. This way is good. Now let's do a name for this. Name it whatever you want. I'm going to do cow stop hitting my mouse. Cool. We have a name. The roughness is going to default to rough. So we need to input the thickness, the conductivity, the density, the specific heat capacity, and the rest will autofill as well. So we have the conductivity and the thickness. We still need specific heat capacity. I grabbed a relatively general spec heat capacity for a wood fiber insulation that we're going to use, or you can use whatever you want really, but that's what I'll be using, and that would be 0.0023. Specific heat capacity, there we go. So we'll move the cost down because we'll get to that in a little bit, but right now what we're going to do is we're going to get a list item. We're going to use a lot of list items today. We need 2 of these. So we're going to put, let's swap these around so they're correctly organized. The insulation thickness goes into one. The insulation conductivity goes into one. And then from those, input them into their correct spots over here. And now what we're going to want to do is get a gene pool. We only want 1. And we have 4 items, so we count from 0. So maximum, put 3, and then take away the decimals. Cool, nice. Now let's go WLC_2, because it's a surprise tool that will help us later. And now we're going to go index, and now when we change this, and what we'll be changing during the simulations is, why are you not doing stuff? Density, yeah. 320 is going to be a decent average for wood fiber insulation. I Googled it on a previous take. So let's put that in density, and there we go. So when the slider moves during the simulation, because these are genes, it is going to change the conductivity and thickness in the output in the order of these lists and their assigned values. So we're going to be able to go through and get 4 different options as it comes to the insulation. Cool. So that's done. Now we'll do a list item for this already, but then we'll come back to the money part. So list, index, and now the same thing, as it goes through, per square meter the cost is going to change, and we'll math that out in a little bit. But right now, let's double check that. Yep, we already have that gene pool. Cool. So for layer 1, let's set up our Energy Plus or Honeybee call from EP construction library. I call them factories. So we have our little factory. We're going to want a panel to put our keywords in. Another panel to read from EP materials. Now I know there's a way to make it so the panels don't come out with saying panel on them, but I haven't looked it up yet. So if anyone wants to tell me what that is, that would be cool. Another, we want another list item. List item. And what I like to do is, for the index, we'll do a big range number slider, just so we can punch in whatever value we want. So we want some siding because we're making walls, so let's punch siding in here and then see what the preloaded Energy Plus construction library has. Nice. Let's go with wood siding because carbon. So 1, and then we're going to get some data capsules. Copy it a bunch of times. So our factory's set up and good to go. Put that in here. Now we're going to internalize data. So the output is still wood siding. Put that down here. Connect that into layer 1. Now this is going to error out until we fill it up all the way. Now let's say our next layer is our insulation. Cool. Now for this layer, let's do a wall space air gap. We won't get too fancy with stuff right now. I'm just wanting to share the fun workflow. So we'll do air, wall, airspace, resistance. Perfect. 1. We're already at 1. So let's grab a capsule. Pop that in here. Internalize. And now what do we want on the inside? I don't think anyone else would want Shosugi-ban on the inside of their house. So let's do gypsum. And I actually don't know that. I've never Googled if Shosugi-ban is used on the interior of just something I would like. I have not seen. Let's go ahead and get 19 mil gypsum board. Internalize, zoom out, zoom in. I'm sure that's confusing. I apologize. And cool, we have our construction. Nice. So what we're going to do is these two surfaces, as we saw before, are that face and that face. And we're going to make these two, hold up. Yep. Geom. Nice. Cool. So let's go up here. Since we're going to have all of our walls the same, we can just organize a little bit and press forward. We still have to make constructions for the floor and the roof. Those just for, we'll make some prices and stuff for the roofs. We'll get swifty. All right, so first things first, we need to get a little organized. We need to name our surfaces. So I'm just going to do wall, copy it a bunch of times. Oops. Cancel. Do wall 1. Wall 2. Wall 3. OCD. We're going to take another pause here in a couple minutes just because I will start messing up and have to start over. Wall 4. Nice. Okay, so these are all walls, so we're going to set everything the same. So what we need for surface type is an integer, or string, I guess. So we need wall, that's going to be 0. So let's go 0. And then we'll just pop that into all of the surface type gets. I wish we could, yes, cool. We'll just hide that because oops. Okay, and then the boundary condition is going to be outdoors. And then we'll just pop that into all of these for the energy plus boundary condition. So yeah, now we have our walls. Cool. What are these? Okay, roofs. Yeah, I'm gonna take a quick pause